So today we will see the series and parallel combination of resistances and solve some numericals. See, we are not going to derive the relations, but the two important results you should know is Rs equals to R1 plus R2 and so on. If more resistances are there in series, we will simply add those resistances, and R1 by Rp is 1 by R1 plus 1 by R2. Yes, this is the two important results in finding R equivalent. Apart from that, a few concepts you should know. The concepts you should know or you should remember is that if we have two resistances R1 and R2 in series, if we have two resistances R1 and R2 in series, then current in both of them remains same. They have same current, but they may not have same voltage. For example, potential difference here will be V1 and potential difference here will be V2. These two we can calculate. V1 equals to IR1 and V2 equals to IR2. Yes, by using this, whatever current is flowing in that resistance, using that we can find potential difference, and whatever current is flowing in this, multiply with resistance, we can find the potential difference for that resistance also. Similarly, the concept you should know about parallel combination of resistance is, suppose we have two resistances in parallel, then they must have same voltage, they must have same potential difference across them, current is I, so these two current get divided, I1 and I2. Suppose this is resistance R1, this is resistance R2, in such a way that the product of current and resistance is equal to potential difference. And since the two potential differences are equal, so I2 R2 will also give you same V. So what do we conclude? I1 R1 equals to I2 R2. This is the relation we get. So based on these relations, we will be finding the current through the resistances and so on. So we will discuss them one by one in detail. What we will write here as, what is the current? The current is constant and voltage is distributed or divided. The sum of potential difference here is equals to potential difference of equivalent. Suppose we write equivalent as Rs, then the potential difference across this equivalent V is equals to sum of V1 and V2. Similarly, if the equivalent of these two we assume as Rp, then potential difference will remain same for all of these. What will change? The current through this Rp will be the sum of these two currents. Suppose we assume as I, then this will be I1 plus I2. So if we have two resistances in series R1 and R2, the current do not get distributed. And here if current comes, it gets distributed as I1 and I2 resistance R1 and R2. Okay. So here current does not get distributed, on voltage gets distributed. This is V1 and this is V2. And if we find R equivalent of these, suppose R equivalent of this is assumed to be Rs. So if we find Rs, then current, same current which is going through these will also go through this series equivalent. And potential difference across this will be V, which is simply the sum of V1 and V2. V1 and V2. So here V is simply V1 plus V2. Current is same, potential is added. That's it. In series combination. This is series we are talking. Yes. And now coming to parallel. So coming to parallel, how they behave? They have same potential difference, current distributed, same current, voltage distributed, same potential difference, current distributed, the opposite to each other. That's it. If we have a RP, the equivalent resistance, the current will be the sum of these two currents. So I will be simply I1 plus I2. Wherever you have to find what is potential difference, see what is current, what is resistance, the product of these will give you voltage. Current, resistance, product will give voltage. Current, resistance, product will give voltage. Current, resistance, product will give voltage. So here I1 into R1 is equals to V. I2 into R2 is also V. And here also the same potential difference is there, even in the equivalent case. So even capital I into RP is also V. Both, all of these have same potential difference. Here you see they have same current. So V1 upon R1 is equals to I. V2 upon R2 is equals to I. And here V upon RS is equals to I. So this is very simple thing. Apart from that, whenever you have to find current coming out of cell, you will write I equals to V upon R equivalent, means equivalent resistance of all the resistances in the circuit. This will give you current coming out of cell. So you will simply write it as current through cell. I hope you understood this. Yes. Okay, now what we will do, we will see how do we distribute the current here. How do we distribute the current? The formula for distribution of current we will see now. So see this one, I1 into R1 is equals to I2 into R2. Yes or no? So the ratio of I1 and I2, this is what we want to find, each current we want to find in terms of I. So ratio of I1 and I2 comes out to be R2 upon R1. So you see I1 is in numerator, R1 is in denominator. I2 is in numerator, R2 is in denominator. You may also see that this is, all of these are equal to V. So I1 is basically equals to V by R1. So you can see here in parallel combination, because voltage is constant, current and resistance are inversely proportional to each other. Current and resistance are inversely proportional to each other. Based on this, we can derive a formula. Okay. So how we can derive a formula? Let's see. We know RP. Do we know RP? Yes. Yes, we know RP. How do we know RP? RP is equals to R1 R2 upon R1 plus R2. Yes or no? We know this? Yes, we know this. 1 by RP equals to 1 by R1 plus 1 by R2. From there you can calculate. Now, if RP is known to us, can we find V? Yes, V equals to I into RP. Yes or no? And RP we can write like this. So I into R1 R2 upon R1 plus R2. And this V, since all of these V's are equal, so this V we can write as I1 R1 also and I2 R2 also. So if we write it as I1 R1, then you get R1 cancelled and you get the expression of I1. So what do we get I1 as? I1 we get as I1 is equals to capital I into R2 upon R1 plus R2? Yes or no? Capital I into R2 divided by R1 plus R2. This is what we get. Similarly, can we find I2? Yes. Yes, if you put at place of V, if you put I2 R2, then what do you get? You get I2 R2 as equals to capital I into R1 R2 upon R1 plus R2. Yes, R2 get cancel out and I2 you get as capital I R1 upon R1 plus R2. So this is what you get I2 as. So see, very easy. You can remember total current. If you have to find I2, then you will write R1 by sum of the resistances. Similarly, total current, if you have to find I1, you have to write R2 because they are reciprocal, means they are inversely proportional. I2, then I1, then R2. I2, then R1. And everything else remains same. Capital I remains same, total current, R1 and R2, the sum of resistances remains same in both the expressions. So easy to find. I hope you understood. First question which we have is, we have 6 ohm resistance and then we have 3 ohm resistance and again we have a 3 ohm resistance like this, and we have a cell of 30 volt. This is our question. What is the question? Find current in each resistor. Current in each resistor. See, finding R equivalent is easier than finding current, because R equivalent in this case is very easy to find, but current, for finding current you need understanding of the concept. But yes, obviously to find current you need to find R equivalent also. So indirectly it is asking us to find R equivalent also. What are the steps? Let's try to understand one by one, and then only you will be able to solve these questions very easily. First of all, these two resistances are in parallel. Yes. So we can find equivalent of these two and we can write here as Rp. And then we have one more resistance, 3 ohm here. Initially you should make such diagrams, and later when you become expert of these, you will not need to do that. You will understand that the equivalent of this will become in series with 3 ohm. And here in the diagram you can actually see that the equivalent of these two are in series with 3 ohm. So once we find this Rp or the equivalent of these two, then we will have to find R equivalent final. Yes. So let us find Rp. 1 by Rp must be equal to 1 by 6 plus 1 by 3 because these are in parallel. So what do we get 1 by Rp as? 1 by Rp we get as, the LCM is 6, 1 plus 2, and hence Rp you get as 2. 6 by 3, which you get 2 ohm. So basically these two give you equivalent equal to 2 ohm. Yes. So we have 2 ohm and 3 ohm, and potential difference is still 30 volt. Now if we find this equivalent of these two in series, final R equivalent comes out to be 5 ohm. Why? Because we simply add these and we have a cell with potential difference 30 volt. So what is the current? The total current coming out of cell is nothing but V upon R equivalent. So if you have to find current in each resistance, first thing you should do is to find current coming out of the cell, and which is given by total potential of the cell upon R equivalent. Once we have found R equivalent, we can find I, which is 30 upon 5 ohm. So what do you get current as? 30 volt upon 5 ohm, which is 6 ampere. So the current coming out of the cell is 6 ampere. Now the current is to be divided. How do we divide the current? See, it will come 6 ampere, here it will get divided, then they will combine and again it will become 6 ampere. Yes or no? So now we cannot find this current directly. Yes, there is a formula although that we will also see, but before going into that formula we will see alternate method of finding the same thing. Since 6 ampere is the current going in this and 3 ohm is the potential 3 ohm is the resistance, so potential difference comes out to be 18 volt. Simply I into R gives you the potential difference. If this is 18 volt and total potential difference applied by the cell is 30 volt, so obviously this potential difference must be 12 volt. Yes, based on this logic, because this potential difference has to be 12 volt, we can find this current I1 and I2. How to find? Because both will have same potential difference, they are in parallel. So 12 upon 6 voltage upon resistance will give you the current, and that is 2 ampere coming out of it. And again voltage upon resistance 12 upon 3, that is 4 ampere coming out of it. So 4 ampere coming out of this and 2 ampere coming out of this. Obviously these two give us the sum equal to 6, which we get here in 3 ohm resistance. So this is the concept. We have one more formula to directly find this 4 ampere and 2 ampere. We will discuss this question with that formula also, but before that please copy this. The two formula which we get, and the question which we had is this: 6 ohm, or I should write 3 ohm here, 6 ohm and then 3 ohm, and the cell was of 30 volt. Yes. So now you see, if you remember, we just found this as 6 ampere. Yes. So this is 6 ampere and we have to distribute this 6 ampere into these two. So suppose this is R1 and this is R2. This current is I1 and this current is I2. So what we will write I1 as? I1 will be equal to total current, or 6 ampere, into R2, or since we are finding current in this, we will multiply this resistance, so into 6 ohm upon the sum of these, or 9. So what do you get? You get 4 ampere. So this is the same answer we got by the previous method. And I2 is equals to 6 ampere into, since current is we are finding in this, the resistance will be this one, into 3 ohm upon 6 plus 3, or 9. So what do you get? 3, 2. So 2 ampere current you get. The same result we obtained in the previous method. Yes, so this is how we do it. But remember, there is a limitation of this formula, and that is we can use this formula only if we have 2 resistances to distribute current. If we have 3 resistances in parallel, then the formula cannot be used. Then the concept which we will be using is current is proportional to 1 by R. How we do that and how we solve numericals based on that, that we will see now. So here we have this second question. Suppose this is a 4 ohm resistance, then we have a 6 ohm resistance, then we have again a 6 ohm resistance. These two are in series, and then this line goes like this. We have 3 ohm, 6 ohm and also 2 ohm here, and one more 2 ohm here. So what we have to do in this question? We have to find current in each resistance. 36 volt. Find current in each resistance. This is what we have to do. Let's try to do that. Now, first of all, we will find R equivalent. these two are in series, yes, so we will get them as 12 ohm. The R equivalent will be 12 ohm, and then 12 and 4 are in parallel. So 1 by 12 plus 1 by 4, this is what we get. We can directly use R1 R2 by R1 plus R2 also. 12 is the LCM, 1 plus 3, so it becomes 4. So 1 by, this is 1 by RP. So what do you get RP as? RP is, you get as 12 upon 4, means 3 ohm. So here this entire resistance is simply 3 ohm. What about this? So all of these are in parallel. So 1 by RP, you get 1 by 6 plus 1 by 3 plus 1 by 2. What do you write them as? 6, 3, 2. LCM is 6. 1 plus 2 plus 3, or you simply get 1. Yes. So RP, even if you find reciprocal, it will be 1 only. So RP is also 1. Here also RP is 1. Here we have 3 ohm. So this entire resistance is 3 ohm. This entire resistance is 1 ohm. And this entire resistance is 2 ohm. This is simply one single resistance. So what is total R equivalent? R equivalent is 2 plus 1, 3 plus 3 means 6 ohm is the R equivalent. So what is current? Current is V upon R equivalent. Yes or no? V upon R equivalent means V is 36. 36 upon R equivalent is 6 ohm. So we get 6 ampere as the current. So we have 6 ampere here. Yes. Now we have to distribute them. 6 ampere here, when get divided, obviously 6 ampere will be here. So 12 volt is the voltage here. 12 volt. Out of 36, 12 volt is here. Rest are here. Okay. Since R equivalent of entire this current, entire this resistance is 1 ohm, so we can simply put here 1 ohm. So what you will get voltage here as 1 ohm into 6 ampere current. Instead of all these, if we put 1 ampere, if we draw a diagram like this, 3 ohm, 1 ohm and 2 ohm. 2 ohm is alone, 1 ohm is for this and 3 ohm is for this. Then this is 6 ampere current. The voltage here will be 18 volt. Yes, current into resistance. Similarly, current into resistance, here voltage will be 6 volt, and current into resistance, here voltage will be 12 volt. So here voltage comes out to be 6 volt and here voltage comes out to be 18 volt. Based on this, can we find the value of current in each resistance? Yes. This is 6 ampere. This is what we know. What is the current in this? Voltage upon resistance, 1 ampere. Voltage upon resistance, 2 ampere. Voltage upon resistance, 3 ampere. Very easy. What about this? 6 and 12. It is 18. Sorry, 4 and 12. It is 18. So it must be 18 upon 4 or 9 by 2. Voltage upon current, voltage upon resistance gives you current. Again, voltage upon resistance, 18 upon 12, because R equivalent is 12 and the current in both of these will be equal to current in the equivalent, and hence we will write 18 upon 12 and this will give you 3 upon 2. Now if you add these, you get 6, right? So this distribution is correct. Otherwise you could have used the formula also, and also we could have used the concept that current is proportional to or inversely proportional to resistance. So now we will see the method how we use this current inversely proportional to resistance to find current in all these. Here we have used the voltage upon resistance concept, and if we have to use this current inversely proportional to resistance, how we will find that we will see just now. I hope you have done. Take a screenshot and now we will erase it so that we may see the second method of finding the current in 6, 3 and 2. I have already told you two methods for two resistances in parallel. Now I am going to tell you the second method for 3 resistances in parallel. See, if the resistances are in parallel, current, the ratio of current I1 is to I2 is to I3 is simply the reciprocal of resistance, resistance, resistance. So it will be 1 by 6 is to 1 by 3 is to 1 by 2. Now what you do? You simply multiply it with the LCM of these to find the exact ratio. So multiply with 6, you will get 1 is to 2 is to 3. Yes or no? And now you have got the ratio. How will you find? So it must be 1 upon total sum. So 1 upon 6. 3 plus 2, 5 plus 1, 6. 1 upon 6 into total current, and that is 6 ampere, which comes out to be 1 ampere for the first case. 2 upon total sum means 6 equal into 6 gives you 2 ampere current, and 3 upon 6 into 6. This 6 is the sum of these, and this 6 is the total current which is going to be distributed, 6 ampere current. So we get 3 ampere, which we obtained from this method also. Yes. So this is the second method which we may use for distributing the current. In this case specifically, we will use the inverse method. You may also use the voltage method to find current in each resistance, that we have already discussed. That's why we are discussing here. This is 12 ohm, this is 4 ohm, and this is 3 ohm, 6 ohm, 3 ohm, and 0.5 ohm. Okay, so we have to find current in each resistance. Okay, so how do we find? 12, 4 and 3. First find the R equivalent of this. So 1 by 12, 1 by 4 plus 1 by 3, 12, 1 plus 3 plus 4. So this is 1 by Rp. This implies Rp comes out to be 12 upon 4 plus 3, 7 plus 1, 8. So 3 upon 2. So R equivalent here comes out to be 3 by 2. Now R equivalent for 6 and 3 you will find 2. We have found so many times. And then 0.5. So it is 1.5 plus 0.52 plus 2, 4. So R equivalent, what we get? We get R equivalent as 4 ohm. So what is the total current coming out of the circuit? Total current coming out of the circuit is total voltage by R equivalent. So 48 upon 4, or simply 12 ampere. Now once we have found the current, total current, can we find current in each resistance? Yes, that we can do. Suppose these currents are I1, I2 and I3. Yeah, we are using reciprocal method. We could have used this voltage method also, but that I leave on you. Please do it by voltage method also, and try to match it with my answer. So the ratio is I1 is to I2 is to I3. This ratio comes out to be I1 is to I2 is to I3 comes out to be 1 by 12 is to 1 by 4 is to 1 by 3. The ratio will be simply the reciprocal ratio of resistance. And now we multiply by 12 the LCM of all these, and we get 1 is to 3 is to 4. This is the ratio of current we have. And once we find the ratio of current, the current in each resistance I1 can be written as 1 by sum of all these 4 plus 3, 7 plus 1, 8 into total current, and total current is 12 ampere, that is known to us. So it is 3 by 2 ampere. Similarly I2, if you have to find, it will be 3 by 8 into total current. 4 3s are 12, 4 2s are 8, 9 by 2. And I3, if you have to find, this will be 4 by 8 or 1 by 2 into 12. So you get 6. 4 by 8 or 1 by 2 into 12, that is 6 ampere. Now this is 3 by 2 ampere, this is 9 by 2 ampere, and this is 6 ampere. So do you get 12 as sum? Yes, 6 is this and 6 is this. So you get 12 as sum. So you get here 12 ampere, and then this also get distributed. Now this I leave you as a homework to solve. 12, so this will be in the ratio 2:1. The resistance ratio is 2:1. Current ratio will be 1:2. So this will be 4 and this will be 8 ampere. Just find out whether you are able to get this or not, and again you get 12 and 12 passes through this. So this is how we distribute current in various series and parallel combination of resistances. I hope you have understood. If you have any doubt, please tell me in the comment section below.
Let's synchronize.